Today we'll be talking about a thing that you, as a software engineer, most probably doing daily now. That when you deploy, or that when you develop some changes, nowadays you don't wait for a month to deploy this code and see what's happening or what's going on. So this thing you're doing on a daily basis. If you're not, then you are far behind. So for us, this thing should be as easy as possible and also reliable in the way that you can predict what are you deploying and be able to go around with your changes and to know what are going around. So at the beginning I will be talking about how we used to deploy our applications and our changes before using Autoscaling group from AWS, and how we used AWS and the services from Amazon to make our life easier regarding deployment. So the first part I will be talking about the process, and the second part Martin Roos will be talking about the configuration of the application, how we manage these, and the secrets management. So first, how actually we used to do it before. We used Capistrano with some magical scripts, and you as a developer just develop your change on your machine, run tests on your machine, start deploying from your machine, and then hope that everything goes well. And this part of the problem, that everything you have to do it from your machine and not in an automated way. So the other problem with this way is that you have to go now access the machine and configure. If your change requires new password or new username or whatever, new configuration, you have to do it manually again. So the developer has to access the production machine, or first the staging, if you have staging machine, do it, see the changes, then you have still to access the production machine, and hopefully you can get everything done. And if something went wrong, then good luck, open README if there is one, and if you understand what's written there and how you can roll back or rescue whatever going on. So that was how we used to do it. But automation is your friend most of the times, not always. Most of the times automation is a really good idea, and let the machine do everything for you. In that way, it's kind of predictable and eliminates some human errors. So we started to list down what actually we need for our deployment process. So first of all, we need repeatable deploys. Repeatable deploys here means that I need to know what exactly I'm deploying, and this change, what's required for this change to be deployed. And if this deployment or this set of change I just deployed is really bad, I need I have to have easy way to go back for the previous state for this machine. So that this brings us to the immutable deployments. One thing about what I mentioned before, that accessing the machines and configuring manually the secrets, we have seen that this develop like really bad habit for the developers or engineers, because when you know that you can access the machine and you can go and change things around with manually on the production, unconsciously you will just start not giving really attention to your code, or your changes should be really predictable, and you should predict what's going on, not just I will go and see what's going on wrong because already the machine is there and I can access it. So that was one of the most important parts we wanted to have, and also to have automated versioning and configurations. In that way, that me as a developer, I don't want to know the password, or I don't want to have access to any production machine or even staging machine. For me, I'm really happy if I know nothing about any passwords, even my account's password, everything. I'd rather not to know anything. So that part also we want to tackle down. So the next thing is to increase the capacity during deployment. One of the things, if you have an application or a service which is deployed on, let's say, 4 machines or 4 instances, during the deploy, if you just go directly and deploy to one of the instances or 2 of them, so you risk your half of the traffic, or just risking with the capacity of your processing the machines that process your traffic. So that was also one of the problems we want to tackle down. And as I said, like, and also one of the last point is really important. Me as a developer or DevOps or any person who works as software engineer, I don't want to wake up in the middle of the night just because one machine went down or something. This should be self-healing enough, and the machines are smart enough to tackle this down for me. I don't need anyone to wake up in the middle of the night to fix something that the machine can do. This is the most important part. Windows users, for us, were like struggling with Ruby setup and having the environment, the correct dependencies to be able to deploy the applications. So we wanted to make it easy. And as you can see, it's really just that easy. Some of the Amazon services, we were able to create or develop a framework that enables us to have this deployment process as easy as possible. So for us, how we will do this, we need that every set of change you develop, it has to be versioned, and you have to know what exactly this change is doing. So versioning is really important part of the development part and deployment part also. So, and also I want that when I deploy, this deployment, like the code shouldn't go into staging or production or any environment without being tested. So this one, maybe I just run the tests and then I found, okay, I fixed the test. Then I just deploy it again without rerunning tests because I'm human, I forget. But if the machine does that for me, so now I'm pretty sure that nothing will go to the production without being tested. So this is also one of the things that we pointed out that we want to have. And managing the secrets, as I said before, every change, if I changed something, if I changed the password for storage access or anything, and then I found out that my deploy is really bad, the old way, I have to go back into machine manually and change it manually, and hopefully I have like this secret, backup of this secret somewhere to get the correct secret, and all of that happens actually while your traffic's down, if it's in production or something. And however you're experienced, once the production is down, you will get panicked. This is like we have seen that, however experienced, you still get panicked and try to figure out what's. So with this pressure, if you really have to go and find out where is the password or the configuration, then that's a not good situation to have. And also one important thing we needed, not just versioning, we have also to know that this bad version, I should not deploy it again. So the machine should be smart enough to know that. So now I'll just show you like the process for the deployment. So if we have this application now, which we have already a version of this application, 1055. And getting the traffic, and you can monitor everything. So when a developer decides to create some changes, to develop some changes, and pushes these changes to the VCS, after that, the build server will start automatically to pull the changes, runs the test, and make sure that everything is okay. And this is a deployable change. So after that, if everything succeeded, it will just ship the package into SS3 storage, where we store all our deployable version or package of this application. And one important thing here, that with Amazon, and I am like the control over the roles, this enabled us also that when you deploy one application, this build server will be able to access the resources of this only application. This one also one of important things, but we will need like hours and hours to talk about management the roles. But for now, just the build server will just upload here the package, and after that, here the developer will just have to click one button that says, okay, I want this into this environment now. So once the build server will invoke the CloudFormation APIs to create a new application with this version, which is the next one, version 1056. And after that, here's the important part. As you can see here, the configuration is in a different bucket, and they are totally isolated, and they might be in a different account. And the application here goes and has access to its bucket only and gets the secrets from there. This eliminates the part that I don't want to do. I don't want to go and give it this password and make sure that yes, this version is this password or this configuration. So it's here and secret. So at some point you can have even like zero knowledge about the password if you can automate this also in a way that DevOps just generates the password in some way and put it here for the application. And after that, gradually the traffic starts to go to the new instance. And at this point you have to verify and validate that yes, everything went okay with your deployment and it went as you expected and as you expect it to work. So when you are really confident of that, with also one click, you just tell the build server, okay, I want to keep the newest version of the application. So here CloudFormation also will help you to get rid of this version, and then after that, the new application will. So this is the abstract of what's going on. That's how the new application, and these are like totally different stacks and totally different machines, and they are immutable that no one can go there. Like the access to this instance is not that easy to go, at least for the developers, most of the developers. So, but life is not that easy. When you deploy something, even when you deploy to staging and you verify it in your local machine first and then staging, and shit happens in production, maybe it's a different. So still, at this point, you don't have to panic or to do anything. Still, also with one click, you have a rollback button that says, okay, I don't want this instance of machine. This change was really bad. Bring me back to the previous one. So here, CloudFormation, and because like we keep here all the changes. Here's like the what we mentioned before. It's repeatable deploy. So I can bring back what was before here without any hassle. And this application also knows its secret and knows the version, and it can get it easily. So I don't have to worry about this at all. And this is the main, the abstract for the flow. And here we will show you Martin Roos will start to show you the demo, and after that the configuration and how we manage the secret.
Totally lost the cursor here. No, that didn't go as planned. Where did I click? So, as it works, developer makes a change to the code. That's your normal work process. Committing the stuff into the repo. Usually we also include like ticket names and stuff, but just for this demo we left that part out. Obviously a pull request needs to be created, so nothing goes to production without a pull request and a code review. Sort of essential, at least if you do payment software. You don't want to do, oh, I fixed this, and then it costs the company like thousands of euros of money, or tens of thousands. A really bad idea. So here is Tanel approving the pull request. Mostafa at that point continued with the building of the package itself. During the building process, the machinery throws up the WAR files into S3, and what's really important is that the same WAR file is for both staging and production. It just goes into different buckets because according environments have different access, but the code is identical. It's made from the same moment of time. So you don't have the moment that you build something for staging, you mess around, and then something else goes to production. So once the deployment process itself has started, we have a nice graph showing what's going on in our machinery. We wait for the new machines to show up. Some of the graphs are like machine independent, but we are rapid like queue consumption graphs here, and they will start to show new machines at some point. This way we know that, okay, they came up, they were actually healthy enough to start processing traffic, and they started doing things. At this point, we take a moment just to analyze if everything went fine there. If we figure out that, okay, the new traffic was healthy, we didn't get any exceptions, any errors, performance, nothing else changed, then we tell the machinery, okay, just keep the new stack. I don't need the old machines anymore. For that brief moment in between, we have right now double the capacity to handle anything. So if anything goes super bad, we haven't lost any like processing power. So that was also very important for us because with old schemes that didn't happen. We filtered out the traffic here just for one of the old nodes to see that it eventually starts to die off and doesn't emit any kind of new messages anymore. So we know that, okay, the node is gone, without having to like SSH into the node and figure anything else out that's not around anymore. Why we do this over Kibana and not over any other tools? We have really a big set of applications, and I don't want to know where they all are. We throw all the logs together into an Elasticsearch cluster, and Kibana can show us the stuff, and we can reuse the graphs for various applications. And yeah, that was pretty much it. From the graphs, it was visible that the nodes went away, and the new ones were there. I wonder if I now can manage to hack myself back into the slide, the clicker stuff. So, when a build actually is going to be deployed, we tag stuff in the repos. And also when the rollbacks happen, we tag them as bad ones. So we know that when we again go forwards, we actually skip those guys. And if we ever roll back again, like from the next version, we don't stumble again on the bad ones. So here we can see the tags. If something was rolled back, the bad version happens there, and we know that this is a no-go version, we shouldn't ever go back to this one. So, about the config, why is this even important? Like, who cares? It just makes stuff work, right? It sort of comes down to the experience, like if you're in the DevOps team or you're not. As a developer, you always think, oh, there's always time to fix stuff, you always know stuff, everything is super fancy and easy. If you are actually a DevOps person who wakes up at 4 o'clock in the morning to a dying machine, the machine is gone, the only config was there, you're like, well, now I'm screwed. You go maybe look up some readmes or just look at example config, start to restore it. Big clients don't really like if your services are down, just for such reasons. And yeah, sure, you could have some kind of maybe backup of the config, but then you also have to know where to fetch this one from. What's appropriate for this machine? Right now, our production is running in over 300 machines. I don't want to know the config for all of those. I'm just a human being. I like to sleep at night and don't even know that the machine went away. So when you look at any kind of config, there are like different levels that you have for stuff. There is some easy stuff, like when it's logging, what's the prefix, where is the database. Database credentials is not so easy anymore, because as a developer, maybe you don't even know this. You shouldn't know this. You don't care. Somewhere is a database, somewhere is a password for it. I want just the application to connect to it. There just has to be some kind of agreement how we mark down that this is there, but I don't want to see it anywhere. And like when you think about it, if you have sometimes, let's say a bad case, somebody logs down the password, you should change it. But how do you organize even this thing? There is a like small advice here that don't change any passwords. We don't change secrets. It's a bad habit. If a secret goes bad, create a new one. Then you will have the old version and the new version of it. So if we try to categorize those things, we will figure out that actually some stuff is very machine dependent, like the instance ID, type, startup time. There's also some other stuff like IP addresses and so forth. But for us, they're not really important. I don't know where most of our servers are. I only care if something goes really, really, really bad. In other cases, I don't care. Then there is something that's sort of like environment dependent. Your staging database is in one host, in production it's in another. But it's not really a secret. Like database password, yes, database location, not so much. I mean, if it's anyway in Amazon VPC, internal network, even if anybody knows what the name for it, they cannot access it. Really tricky. And yeah, there is stuff that actually is something that you can, say, safely put into the configuration file, which is always valid for this application. If my application is called, I don't know, SMS history for our case, well, its logging name is always going to be SMS history. The environment has never like override this to something else. It's not suddenly becoming, I don't know, update publisher or something. That's always going to be one thing. So we figured out that, okay, we will group stuff. And the stuff that we get from the Git repository gets into the same packages as the code. It's in the same repo, it's tagged in the same ways, in the same change sets. So if I change something about the database, let's say database implementation detail, I add a new timeout value. I also add the config for this in the same version of stuff. It doesn't go anywhere else. There is no separate config repo in that sense. Always the config and the code, they go together. That always sort of works nicely until you get to the secrets part, because the secrets you don't want in the repo. If you throw a password into the repo, you need a new password. If you throw a private key in the repo, it's not private anymore. Obviously not a very great idea. So, something that comes out here is that you sort of need to version secrets. We just give them different names. So if you see that you have a database access, you have a database password. And if you change it at any point, you probably don't want to start using it before or after the deployment, like too late. And also actually if you roll forwards, you made another code change that broke something, and you go back, then you don't want to cross-use like database usernames and passwords. And that will end really bad. Also in the same sense, like, let me think of a better example maybe. I don't know, certificate passwords, stuff like this. Any kind of secret I can actually think of should be versioned, because you want to change that at some point, but you don't want to go into a state where you can't go back. If you have a server which has a local config and the files on the disk there, you put as an admin the password in there. If you change it in the middle of the night with a typo, bad. If you have to run chef just to update this one value, it's also somewhat bad. That takes a lot of time, and it's also error prone in the sense that now you will have 2 repos of stuff where you keep stuff, also the data bag of chef. Stuff gets even more interesting than you want, especially in the middle of the night. Like in the day, we can all be heroes with a sober head to everything super nice. And here we have something also as well that the stuff that we eventually figure out is that we have an app properties file which is overriding the whatever kind of default sections. So if I have a default section for like database, then I have something called app properties which can just override parts of that if I want to. I can have reasonable defaults, database timeout, maybe even the database username if I use the same one in the staging and production, but probably the passwords differ, hosts differ, and so forth. So we do sort of like a merging of the information, add them together. There's also the local info from the machine, which we don't want applications themselves to figure out, because that would add additional logic to them, and it's not unique to the application. It shouldn't go and invent stuff like on its own. Like, how do you find the instance ID of this Amazon machine? You don't think it's useful until you get a crashing machine that randomly crashes and you can't figure out which one of the 10 ones it is. So if you have the ID in your hand, you go, okay, that machine is acting funky, but it's not failing all the time, so it's not removed from the cluster. Then the instance ID comes in handy, and that's when you use it. So, I already jumped past that. Well, I think I have missed actually a slide then. Something that we use in our config, just to keep the stuff in the like repos say, is that we use placeholders for the secrets. So you actually can take inside the repo, look at the file and go like, okay, the secret we will put here for the staging environment, or as production has a different like, template file. Here goes the production like secret value. But you can actually just take the staging and production configs and you can diff them to each other and figure out why does it work in staging and not in production, what have I done? If you have local configs in machines or configs organized by some other tool, then you as a developer are like, well, maybe I need to ask the DevOps guy what's different here or what's going on. Or you can't ask anybody, or you make a ticket to another department, which is even more awful. Sometimes happens in some companies, just to figure out like what is different in those machines. I don't want to puzzle myself around it. I don't want to go into the machine to look for it, like what's going on. And also across the versions, if I deploy 1.10 and 1.20 or 1 day later, I figure out, okay, something is really weird here, what has happened? I can diff the configs to figure out, okay, Mostafa came along and added a new config value, which shouldn't be there. And also the, like, again, like if you do financial stuff, then tracing the moves that anybody has done is important, at least to the point to understand why they did it. It's not always that somebody has done a bad thing, but sometimes you just look at the config line and go like, why is this here? Just somebody has overrided the timeout production value for database connections. Why did this happen? If I manage it anywhere else than in my Git repo, then I suddenly have to track stuff in multiple places. Okay, I worked on this ticket, I made this change in the Git repo, or maybe now into the chef role, whatever other kind of places that you have, and then you have to bind it all together when you start to like root to the problem. If you just have the application's Git repo, the config is there, the code is there, you have one commit that says, okay, I had to increase it because at random Amazon doesn't give me the RDS connection fast enough. And yeah, that's pretty much how we stitch together. I have put a secret in here as the visual what happens, but what happens in reality is when the application comes up, it extracts the template files from the application R file itself, pulls the secrets that only this application has access to, replaces them in. Now the application config is complete and you can start it. something that we didn't mention before is that the build server itself doesn't have access to any of the staging or production secrets, because otherwise it would be a godlike machine. It can do anything. If I hack into this, I'm king. I don't want any node in particular to be in such a king position that can just do it. I can do anything I want. I can access all the passwords. Like, this is crazy talk. Why should this happen? I have seen some solutions that work like this, and I'm always at always like, why would this node even have the access to the other node's passwords or secrets or whatever? So that's kind of odd, let's put it this way. Should be really restricted down. Now I can just jump one slide forwards. So, something that wasn't throughout explained before about the service discovery. Anyone here is using ASG and ALB together, or ELB for the matter, doesn't really matter. I see one hand, not that many. So what in essence happens during our deployment moment is that we tell Amazon, here is the standard dummy that we have for all the auto-deployed machines. We renew it every now and then to a newer version, and also this actually is referenced in the Git repo. So if I upgrade the dummy that I go to, you can see it from the same repo of the source. So it's not anywhere else hidden in the magic corners of the universe. If I decide that I upgrade from Java 8 to Java 11, it's seen in the repo. As we tell Amazon, okay, create this tag for us, this autoscaling group, we also tell this is the load balancer where you keep your stuff in. And the load balancer will be notified of all the nodes that have been started. So the load balancers, we use different kinds. For the applications that have actually HTTP traffic, they have obviously properly configured like web server-like load balancers. And we also have dummy load balancers which don't accept any traffic. Amazon shows us a big warning sign. This ALB is misconfigured, it doesn't work at all, but we actually don't need even that part. Those machines are standalone, they only work on RabbitMQ, and the only part where we need them is for the health checks. So the ALB sees, okay, a new machine came up, I will pull its status endpoint. The machine will say, okay, I read all my config, everything is super fine, I'm healthy, I can do stuff. Amazon says, okay, you will be in service. If the machine comes up and says, I can't really access any of the network, and you would think it doesn't happen, but this happens. Machines start and they say, like, I can't do anything. I can't connect anywhere outside. And then ALB also decides that, okay, that machine is not healthy, throws it away. If you have such like total death situation where the application that you built was fine in your machine, fine in staging, but for some reason you have misconfigured something horrible for like production, like the other service that's supposed to use something like this, they will start to flip out. They come, they say like, oh, I'm not feeling so well, and they will go away. And Amazon will not give any traffic to those guys because it sees, okay, you're not healthy, you're not healthy, you're not healthy. That's down to you to spot this and figure out that, okay, not really that great, but it has some stuff, like the capacity stuff. Most of the stuff computers work fine, and you're like, I can always rely on the server and it's there. Machines actually die randomly. It happens, like it depends on the luck. Sometimes the machine gives you warning, sometimes it just disappears like this and it's gone. And that's also when the ALB actually spots the status endpoint is not okay anymore, but for this autoscaling group I was told I need 5 machines. And now 1 machine is down, so it will spin up a new one. Has some nice parts, has some ugly parts to it, but in general, if you want your service to be up, it's very nice if there is something out there that actually pulls them up for you. With status endpoints, that's down to you as a developer to make them actually useful. Like from our example, sometimes we have spotted that Amazon doesn't have total outages. We use their services mostly in Ireland. And sometimes we see that one of the availability zones gets networkless to like when talking to outside. And then you can actually see around it, okay, in that availability zones I started to lose machines. and they popped up in other ones, because always in the ASG we tell them be at least in 2 or 3 availability zones. 3 is usually the one that we go for, because just most reliability comes out from there. And yeah, the ASG is just, they're very helpfully fulfilling the ALV's commands. Machine is gone, let's spin up a new one, it comes up. Amazon has like certain policies, you can configure them, like how the ASG decides where the new machines come. So you can tell them that, okay, I want them to appear in this order or that order. And when you drop them, do you want to drop the oldest machine or the machine in the most populated availability zone? That's down to you, you can configure it. We are mostly running on default, which sometimes has ill effects. Today, Amazon told us, okay, those 2 machines that you are running here, they will go away. So I had a choice, I can wait until Amazon actually drops them one by one, and my ASG will create new ones, or I can just say, okay, I want other machines. In that case, I can tell, okay, I actually don't want to have 2 machines, but I want to have 4. And sometimes Amazon does a funny thing that it figures, okay, you have 3 zones configured, 2 machines are right now in zones A and B, and it will come and create 2 machines into zone C. And you're like, now I have 2 machines running the code, but they're only in one zone. And Amazon doesn't really help you in the case like, okay, maybe that's not the best idea to create 2 new nodes into the same availability zone. But usually you can just provision more and drop them later, and you will spin out from that one. And I think, yeah, that's pretty much with the talking part. I'm not sure I left anything very important out, but I think now we have time for questions, right? Should we use the other mic for the questions? It's operational, I think, right? Let's see. Does it work? No, the mic doesn't work. So okay, we can do it this way. We send this mic around, and I will just talk
really loud.
Really loud. No, so if you want to have something from Mostafa, you can just directly point at him, and he can respond to it.
Raise your hand. Questions, yeah. Questions. Okay.
Hello, thank you for great presentation. It's a bit out of the topic, but more like sales management is like that. 2 questions. Do you know anything about ITIL, which is very popular IT sales management processes?
I didn't pick up the word. Come again?
ITIL.
No, we
No.
don't.
Okay. Second question. Okay, you talked about automation very much, yes.
Yes.
But what about if customers claiming that there is a problem, or they want to, they have passwords, but then there will be more and more problems on the customer side. You still use the same process, or do you have a different approach, or because the first goal for any IT service is make money, service the customers. So maybe you're not the right person. I don't know. You're not technical, but that's the question. Okay.
That was a very round-shaped question, but
we can't hear it.
okay. So I can grab the mic back. So our company's main focus is actually to do payments. That's what we do. We have merchants who tell us we want this payment to happen, and our goal is to make the payment actually happen. Our goal is not to produce software as such.
Sorry, payment, the whole customer, maybe payment does not happen. Customer complains, payment does not happen. Even if your testing is okay. Yeah, what happens then?
We have a customer support team and those pieces.
There we have customer support, but as you saw before, we had those nice Kibana graphs. They actually indicate us of stuff that doesn't happen when it should. So all the applications log down their healthy metrics, how many stuff was started, how many stuff was finished, and we track that stuff so we figure out, okay, something is not completing. We also have like extensively, we have started using synthetic tests. So we always have machineries doing payments the whole time. Right now, as I have spoken here on the stage, we have made hundreds of test payments just to figure out that stuff works. So, yeah.
So you talked about versioning and rolling back. So have you kind of created all of the automation yourself, or are you using the solution to actually do it?
Well, we try to reuse in that regard as much stuff as we can. Because like from logical space, Amazon has made the ALBs and the ASGs, so we leverage heavily on this. Git already exists, we didn't have to reinvent this one. Our job was just to tell the machinery in a reasonable way that when a build happens, when it's good, mark that this build happens here at this moment. And when the rollback happens in the same way, we just tell Git, just with the regular tagging command, this was a bad thing. That part is our custom, but it's really that slim in the sense. We didn't really use anyone else's work, so we couldn't really find one at the time at least that would suit us. There have been like solutions that have been popping up since, but migrating over has a cost and we haven't had the reason to jump the ship yet.
Okay, one more question and then we'll go for break, but don't worry, we'll stick around and we can talk later as well.
Thank you. Do you measure your mean time to deploy and mean time to recover from broken deployment? And what is it in minutes? Is it in 5 of minutes? Is it in half an hour? Give me the perspective.
When we issue a deploy command, we are sort of at mercy at Amazon itself, how fast its CloudFormation is currently behaving. Most of the time when it's good, when I decided, okay, this thing is good enough to go into production as a developer, then I think within 2 machines, or like it depends, like within 2 minutes somewhere I expect it to pop up. Sometimes it's faster, sometimes when CloudFormation is issued, it's slower. But
faster
to answer your question, we
yes.
don't officially measure it, nor do we do any hard
we don't do constant measuring because it's roughly persistent. We only complain to Amazon when we see that CloudFormation is really going over days and I have to wait. 10 minutes is already on the unacceptable side. That's no.
Yeah, and when shit goes sideways, we just move really, really fast to recover. We also had previous questions submitted before the event, so I have one for you guys because I know you love this question. What are the best use cases for AWS DynamoDB? Roos, I know how much you love.
We have used DynamoDB. Well, the promise is great. I mean, it's a key value store, everything super fancy. You can scale up and down as you want. The reality is a bit different in the sense that if you fall any way out from their design model, then you're in trouble. One thing is scaling up and down. Amazon actually limits how much you can do it. So in some ways it's nice actually, like if you can provision that, okay, I will have a busload of requests coming in tomorrow, you can actually tell the database that, well, I'm expecting that much traffic, and it's really easy. You just either you have a build script that sets it up, or you just click in the console, just make it really big. And Amazon actually takes care of this for you. If this seems like, well, how hard can it be? Then you can try with a Postgres cluster to go over a certain limit, and there's a brick wall there, and now you're not going anywhere anymore. So in that sense, DynamoDB is super awesome. If you do any kind of scanning over the record, no, don't. That's going to make you, first of all, slow. Secondly, bankrupt because it's super expensive. You have to pay through your nose in those cases. But yeah, if you have something like from our own use cases, when people send SMSs, we can store those into Dynamo. Because we usually, when we store them down and we have to access them, we access that certain record. We just don't go scanning at random and over those. But if your stuff assumes that you will scan over records, or you need to scale up and down frequently and a lot, then actually no, it doesn't fit the bill.
All right, cool. Thanks, guys. And now we'll go for a break, 20 minutes, grab some pizzas and drinks, and we'll be back here soon.